Hello, Professor Gruhn here. Hope you guys are having fun. And by the way, if we getting through chapter 9 today, we are halfway through the book, and so that's good. Friendly reminder: we are using Murach's MySQL, and we're on chapter 9, which is page 242. This chapter is very long and it's very important. There's a lot of stuff in here. You'll end up using a cheat sheet. You'll Google a lot. How do I do this? How do I do that? It's focusing on string functions, numeric functions, and it's focusing on date functions. Then at the end, there's a little bit of other stuff. We'll see how long this video goes. I'm probably going to try to really breeze through this quickly because the concepts are all pretty straightforward, and I'm not going to go into heavy detail about this little function and this little thing. A little bit of an overview. We'll go through these things. If I need to break it up into, if it ends up getting longer than I expect, then what we'll do is I'll break it up by string, date, numeric, and date functions for that. But this is an important chapter in that you will always use tons of these functions. This is a get the cheat sheet, do a Google on MySQL date functions, do a Google on MySQL string functions, MySQL numeric functions, and you will have a cheat sheet. Matter of fact, if you haven't already, on the Blackboard site, there are some cheat sheet links that if you go out to, you can download them and print them out. And there's tons of cheat sheets out there on how do I do this. And most of the time, you know what it is you need to do. It's just the syntax. One language might have U case for uppercase. Another might say upper. Another might be uppercase. Another might be UC. And so how do you do it in this language ends up being the primary concern, and that's where you have to refer back to it. So let's get started. Let's dig right in. Page 242, read it. It talks about what a string function is. And basically, a function is you're going to pass information into this small program. And you won't see the program necessarily, and it'll be part of the system. Now, you'll be able to later on write your own functions, but here, basically, you put data into a function, and it will return a result. That's different than a procedure. A procedure basically will run and do some operations and not necessarily return a result. So take a look, read 242, and then on 243, it lists a bunch of the functions. We've already used concatenate. It talks about the L trim, R trim, that's trimming from the left, trimming from the right. It talks about the length, how long is a string. Locating, how do you find something within a left function, a right, substring. So read that, and then on page 244, it actually lists out some functions to try. Okay, on page 245, let's see how this works out. Okay, notice here that there's examples of some of the string functions that are listed. And what's nice is you can see the input on the function and the result that it will return. Okay, on the bottom of page 245, there is this select statement right here. And so if you type it out and run it, you'll see that the vendor name is listed, contact name is listed, and the phone number is listed. So a couple of interesting things are happening here. Is that the contact name has the contact last name and the contact first name. And it is eliminating the it's eliminating the comma. Also, you'll notice that the right on the vendor phone, it's actually giving us, counting from the right, the 8 characters. Now, what I want to do here is I just want to add the vendor phone in a pure state. And by adding the vendor phone, you can actually see the before and after. And actually, wait a minute. So to the contact name. Sorry, I was wrong. The contact name is putting in between the last name and the first name was putting the comma space there. So if I put where comma space was star star star, and I run this, see how there's the 3 stars there, and so what I want to do is I want to squeeze in a comma space between those. And here's the vendor phone, and what they're trying to do is they're listing the vendor phone, but they don't want the area code. And here what they've done is they've said, basically, give me a where clause where basically I'm going to get all of this area code. So I know which area code that I'm in. So I don't want to list the vendor, I don't want to list the area code when I list the phone. So you can see that the string function, right, and concatenated with this in the comma space in between the two will, you can use the function, the string function, both in the actual select and the display, as well as part of the where clause. So say if, for instance, you wanted, give me everybody, I want to know all of my contacts with the first name where the first letter begins with P, or something like that. You can actually do that in your where clause itself. Okay, we're on page 246 and 247. We're jumping over to the EX database, so let's use this. I'm going to focus on a table called string table, so let's describe it and look at it. The key thing here is the employee ID and the employee name are both varchars, 3 characters long and 25 characters long. The first example that they give us on 247 is select all of the fields, both of the fields, in order by the employee ID. So let's run that. And notice that it's in order of employee ID, but it is in the order that is being treated as a string. It's the first column is 1, 1, then it's 2, 2, and then 3. So it's 1, 17, 2, 20, 3. So what's happening is the employee ID in this order by is not being treated as a numeric value, it's being treated as a string. And numbers as a string will definitely mess you up in your sorting. Now, remember we talked about the cast, where what we want to do is we want to change it into something else. So what we need to do here is we want to order, it's the same select statement, but we're going to order by the casting of this string variable employee ID has sign, so it will actually be an integer. So now watch what happens to the sort. Now it's 1, 2, 3, 17, 20. So now it's actually acting as you behave because we're treating employee ID in the order by has a cast variable, has an integer. Now, here we go, doing the same thing, but we're adding 0 to the employee ID. Watch what happens here. We actually get an implicit change that takes this numeric value and changes it to 0. So you remember before when we were dealing with casting, we had some funky results sometimes. In this case, it happened to have worked. Now, the other thing that if you notice, that the columns here is that the 1, 2, and 3 is actually in the tens column, and it's not justified correctly. So what we're doing here is using the lpad function, and we're going to basically take that select statement and we're going to pad zeros in for 2 characters. Now watch what happens there. Now it looks a little more normal. The ones are in the ones columns, the tens are in the 10 columns. So if we change this to a 5 and then execute it, notice that now it's 5 digits long. What happens if we change that 0 to a $sign? We're actually feeding it with $signs there and padding it. We're filling the missing gap. And I'm doing a dash. So there's a lot of different things you can do. I think it would be pretty normal to put a 0 in there. Okay, we're on page 248 and 249. We're still using the EX database. Let's describe the string sample again. We're dealing with two columns, an employee ID, which is a numeric value, but while it's a numeric field, numeric data, but it's being treated and it's a string variable. An employee name that's 25 characters long has a string variable. Let's read the data, select star from string sample, and you see we have 5 rows of data there. And now the book's going to say, let's start messing around and locating some of this information. And let's get inquisitive about our data here. So what we want is an index. We want to know what column in the employee name field is the space. What's the first one? And then the other one is and what we're doing is we're going based on the first one. We're giving all the data from the first character up to the first space, and then we're going from the next space up to the next, and that's going to pull out of the employee name. It's going to pull out the first and last name. And notice that while the employee name, that's the full thing, we've been able to strip out the first name and the last name by knowing where the index is and doing a substring, saying only give me this part up to the index. The other thing we can do is we can find out where and put a numeric value, return a numeric value, where the spaces actually are. Notice here, this is the column of the first space, and this is the column of the second space. And here we have some situations where there is a second space, which is actually telling us that there's a first and middle and a last name. So, and we use the locate statement there. Find the first space. And now we're doing a locate within the locate. And that's actually helping us to find the second space. And then a combination of the locate statement and what's interesting is, let's go back up. So when we did the very first one, we actually had the assumption, and so Jean Paul, first name Renaud, Alice von Strump. So von Strump here, we're losing the von part of the last name. And so I think we're going to need to be able to figure out, let's get von Strump in that. I think that's what this last statement is going to give us. And we get the first and second space, boom. Get the characters, and then this very last statement here. All right. Boom. There, so now we're getting von Strump at that point, because it was actually not a middle name, but it was part of their last name. So what's really important is understanding your data, because one rule to pull out your data one way and then pull out your data another way, one function might not work. So let's take an example that I'm very, very familiar with from some data work I had to do years ago. How do you spell U.S. Post Office? And you could, or how do you do like a P.O. box? Let's say P.O. box. It could be P.O. box 123, P-O- box 123. Sometimes it's just box 123. How about the company Hewlett-Packard? So it could be HP, we've seen it. It could be spelt out. I don't know how to spell Hewlett-Packard. I've seen IBM spelt one way, IBM, International business machine. So how do you imagine, how do you know what the rules are when the data, all meaning the same thing, could mean very different? I live in East Windsor, so it could be East Windsor. And it might be East spelt out. So you get the point. So we're actually doing pretty good. We're only 15 minutes into this, and we've just finished parsing a string and looking at some examples of that. Page 250, 251 introduces us to numeric data. So read that, and it does the same thing. It lists a few of the numeric functions: round, truncate, ceiling, floor, ABS for absolute value, sine, square root, power, random. And then it lists some examples of, if you put the data in this way, this is how it's going to appear. That takes us 250 through 51, read 252. Now let's pull up, there's a data table called float sample. Let's take a look at that, and under figure 9.6, there's a few SQL statements we can run. Okay, we're still in the EX database, and we're going to take a look at a table called float sample. So let's describe the table real quick. And you'll see basically it has two fields, float ID and float value. The ID is an integer and the float value is a double. Let's select all the data from the float sample and display it. And what's interesting here is you'll see float ID 1, 2, 3, 4, 5, 6, just auto-incremented numbers. And you'll see some float values. 0.999999, float value of just 1. Here's a float value of 1 point with a whole lot of zeros and a 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 99.004. So what's interesting here is when we start pulling out the information, so let's take a look at float value equal to 1. What are we going to get here? So if I run this, I'm only getting one record. Record number 2 is a float value of 1. Let's look at all of the data. So while 0.9999999 and 1.000000001, those two values from a float perspective are not 1. The truth of the matter is we would probably round up that number up. But what if we were doing something that was very, very precise and we needed that precision? Here, we might actually round that down. And so the true value is actually 1.000000, and that's why when we do this with the float value truly equal to 1, we're only going to get one record. Now here, when we select star from float sample, float value between 0.99 and 1.01, it's going to do some interesting things here, because what's going to happen is it's actually going to round. So here we're getting stuff that's 0.999, and we're getting this one here. So it falls that these statements are all true, where it's falling between the value of 0.999 and 0.101. And here we're going to round this float value to 2. And we're getting the same information. So what we learned here was that when you're dealing with float values, they are approximations, and that sometimes when you're getting your selects and stuff, you've got to be really, really precise about how you look at and look for the data. Okay, remember earlier I told you that a lot of the work you'll be doing in the real world will be dealing with string functions and date functions. And dates can really be tricky, but the good news is that over time that people have, and programming languages and creators of programming languages have actually created a lot of date functions to make our lives easier. So read 254. 255 lists a bunch of date functions, then with some examples of if you issue this date, how will it look? And you can actually, I think, I want to try something real quick, and I think we can actually run a couple of those examples in a basic select statement. So let me try that, and then I'll get back. Okay, it doesn't have us doing any exercises until we get up to page, looks like page 265. But if we, here's something kind of ad hoc here. On page 255, you'll see that there's some listings of some date and time functions and some examples of them. We're still in the EX database. Let's describe the date sample table, and you'll see there's a date ID and a start date. And if I select star from the date sample, I'm getting these 6 records, and I'm seeing the start date for those 6 records. What I'm doing here in this select statement is I'm going to select the date ID from the date sample table, but now I'm just adding a bunch of the functions that are listed at the top of page 255. The now function, the sysdate, the current time, current date, UTC time from the date sample. So what will end up happening is we'll end up getting a row of information for each of the 6 records. And so now you can see the now function, the sysdate, the current time, current date, UTC date, and UTC time. Okay, so if we select star from the date sample, we see these 6 records. Notice that there's 2 records here for February, or 1 record here for February 28th on 2011. So if I do a select star from date sample where the start date equals February 28th, 2011, if I run that, I should get that 1 record. But I don't. The reason for that is it's really not just that date. Also, the value of 10 o'clock is a part of that. So if I want to really include everything in that day, I have to say the start date is greater than or equal to the very first half a second on February 28th up to March 1st. Now this will pull that record for me because we have that value of 10 hours. Now the other situation is we can do this by doing a where clause of giving me where the month and the day of the month, excuse me, the date of the month and the year is equal to this. We'll run that and we get the record. And here we can do it with a formatting where we just say, looking at the start date formatted this way. This formatting actually gets rid of the value of the 10 o'clock. So you start to see how you can manipulate and pull a date just because a date is the way it says it is. Going back here to this select star, is that here we have March 1st, 79, 00000, 00000. But instantly that we add a 10 o'clock or a 13 o'clock or a 9 o'clock, those aren't really those dates. We have to factor in the time when we're considering our select statements. And part of the reason for that too is that this field is called start date. It's not a date field. There is a date field type. This is a date time field. So a date time field data type actually has more value than just a date. And that's helpful if you need to know things of if something happened, when did that happen, not only on this day, but at what time in this day. But sometimes all you care about is the date. So remember, there's types of a date time and there's types of a date. Okay, in the last set on page 264 and 65, we were focusing on this date time data type, and we were focused on pulling out data based upon the date aspect of it. Now on page 266 and 267, we're using the same data, select star from date sample. We're using the same data set, but now what we want to do is extract data based upon the time elements. So again, in reverse, if I say select star from date sample where it's equal to 10 o'clock, I get no records because I also have a date on top of that. But if I use a date format function to the start date and I just grab the time element, now I get that record. And what if I want to extract from the hour, hour and second? Now what I'm doing is by using an extract, the hour and the number of seconds, I can pull that record out. And if I extract the start date equal the hour equals to 9, I get the hour being equal to 9 here for record number 6. And what if I want to get that happened within a certain time period? And then I get this, and I get these two records that happen between 9 and 12. So what happens is, say for instance, your database, your computer is putting in records all day, all long, whatever. And you got this, your boss has got this feeling that maybe something's happening at between 1 and 5 o'clock, or 1 and 3, maybe 8 a.m. to 10 a.m. That you have a computer updating, and you could actually take your orders that are being time date stamped, and you can run reports sorted by the time and do counts based upon what time of day across a whole month, across a whole year, what time of day by day do you actually get your busiest orders coming in. So being able to have a time date stamp and parse out it by date, maybe even by day of the week, where you can get Monday, Tuesday, Wednesday, or by time, you can start getting some very good information about your data to allow you to make good business decisions based upon the reality of in this example, of orders, say, coming into your system. Okay, so now we're going to actually get into some SQL programming, MySQL programming within the select statement. We're flipping back now to the AP database, so let's use AP. Remember our invoices table. Let's look at the invoice number and the terms ID, so just do a select on that. See our invoice numbers and our terms. But now they're adding a case statement, and that's this code right here. And I'm going to take the word terms where it's in lowercase, and I'm going to put it in uppercase, terms. And I'm going to execute this. And notice that our invoice number is still displayed from row 6 here. Our terms ID is displayed. But then our next column in this case statement is when the terms ID, or in the case of terms ID, when this is equal to 1, I want you to print out due date 10. When this is equal to 2, then print out this. And as an example, I'm going to take this and pay me in 30 days or else. Let's run that now. So here, Nete, pay me in 30 days or else. So basically, we're still getting the select, the invoice number, the invoice ID, and we're doing an evaluation of the terms ID column, and when certain things are true, we're displaying certain textual information. Another way is when the using case statement is based upon now. So here, remember we looked at the now function earlier, the date function now, which is right now, today. If it's greater than 30 days, hey, you're past due. If it's less than, greater than 0, but not greater than 30 days, it's 1 to 30 days past due, else you're current. So if we run this, you can see here, all of our invoices, in this case, are past due because of these dates. But we can do logic that basically allows us to say, based upon today's date, we can do some information and come up with results. Okay, three other functions, and this is the home stretch of Chapter 9. Three other functions are the if statement, the if null statement, and the coalesce statement. The if statement is if something is true or false, replace the information with this text. So here we go, select vendor name. If the vendor city is equal to Fresno, say yes. If it's not equal to Fresno, say no. And give us a column name of is city Fresno. So I'm going to select that, and you can see we have no, 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 yes, 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 no, yes, no, yes, no. So that's the if statement. If null, so we have sometimes when we have data in a field that there is null values, we can say something like, remember we have payment date. When people have paid their invoice, they've put a certain amount of money in. That's great. But what if there's no payment date? That means there's no payment. So if the payment date field is null, display no payment. And then if we scroll down, it's down a ways, there we have some null payment dates and no payments. And matter of fact, if I want to get a little tricky here, order by descend, I think, and we do this. Now look at, I'm getting all my no payments first and then my dates. So now I know right off the top who hasn't paid me. And the coalesce says if the field is in fact null, I can replace that field with some information. The same type of thing of where I'll put data into that null field. Coalesce, where what we've got going on here now is here the new payment. No payment is listed in there. Okay, guess what? We are more than halfway through the book, and we have finished Module 4, which means we are halfway through the class. So hopefully everybody watching these videos and doing your homework assignment for CSC230, Manchester Community College, that you guys are ahead of schedule, and that'll be great. If not, if you're not caught up and don't have homework assignments done, you better hurry up, because you do lose points when assignments aren't turned in on time. But the good news is you've had some hands-on driving experience with data that existed. And by playing with and looking at data, dealing with functions, dealing with string functions, numeric functions, date functions, and the like, what you've learned is you've started to get an idea of how databases work and think. We've learned about CRUD, where we create, we read, we update, and we delete data. We've learned about select, where clauses, joining tables together. And so we've done some really good driving of using existing data. Now what we're doing is we're getting into section 3 of the book, and we're actually going to be talking about stuff that a lot of the books talk about in chapters 1 and 2, and that's database design. So you've got a lot of SQL code that you've written and played with. You should have a good understanding. So now let's dig in and start designing our databases. And for your final project, you will be designing your own database. So really think about a practical business case where you're going to need a database to do something.